Hello everyone and welcome to the video. Today I am here on behalf of Team Jarvis to help you explain our problem statement thermofusion, which works to enhance the resolution of thermal imagery. This is a ISRO problem statement. The problem statement says that there are low resolution thermal IR data which misses fine scale variations. Now, there are two types of main inputs when we talk about this, and one is thermal data, which lacks sharp textures, and optical data, which has good sharp textures but lacks thermal information. So here we have to combine both of their qualities into one output image, which would show both sharp textures as well as thermal information. So for that, we have made a multi-sensor agent which will do this work of merging both of these textures smoothly and making it as well as sharp textured and thermal information based. For this, we are using guided super resolution where we use optical edges, textures, and line curve boundaries to sharpen the thermal map and multi-sensor alignment to precisely co-register both optical and thermal imagery. Also, physics informed priors are used over here for effective and well overlapping of both of these inputs. This idea is very scalable and efficient in the long run. So this is the technical approach. Basically, we have currently created some sample TIF files which are based on a combination of both images, the optical input and the thermal input. When this is data is inputted inside our model, it basically divides it based on bands. This image contains various bands and the model recognizes these bands and converts them into three different types of images based on these bands. Now once these images are taken apart, then our model helps with the help of geometric alignment extracts the optical features and the thermal data. This feature extraction once done, then the model fusion happens where the main work is done of fusing both of these inputs into one. This then leads to visualization. Once this model fusion is done, then it is visualized, and this visualization is then even evaluated by the model to give us the quality metrics, the important quality metrics, that is PSNR, SSIM, RMSC, and confidence. And moreover, this visualization is also downloadable in PNG formats directly, and the quality metrics are also downloadable in PNG format. Now, the feasibility and viability of the project is technically feasible because we are using all the programs and everything which are currently available and free to use, which also makes it economically viable for us. Then the impacts and benefit. High accuracy outputs are generated using our model, which is the biggest benefit of all. Environmental and agricultural agencies impact is high because they can detect crop stress and droughts with improved spatial details. Then governments and policy making will also be impacted very well with the help of this. Then for the benefits, AI guided super resolution helps in multiple things such as accurate surface temperatures, then fusion of optical edges and textures, and fine boundary preservations, and many more. Now, without wasting any time, I would like to take you to the prototype that we have developed for a model. Okay, so now we are here on a prototype. This prototype is developed by us, and here first we get started. Now there is a sign in page, but there is no need of sign in over here right now. You can really go in and just go to the quick demo access. Now here it asks for a TIF file. So I'll just go ahead and add one of our sample files over here, and then I'll click on process TIF file. So while this is processing, I would like to tell you about our model that currently our model is quite accurate, but the things we aim to improve is that the processing time. The processing time of our model is currently very high and we would like to reduce it. And also, yeah, over here we have already got the output. This is the output of our image that has been uploaded, and for the reference we have also provided the preview. So once the TF file is uploaded, this gets separated into three different bands over here. As you can see, the optical false color, thermal, and optical true color. Okay, these are downloadable over here. Let me show you. See, these are downloadable in PNG image formats. Then this is the analysis view. So this is basically the comparison between, you can say, the predicted output and the input that we have given for the thermal data. And this is the error map over here. And this is the edge analysis. The edges that has been protected by the model are shown over here. And the statistical analysis, that is the comparison between the actual and the predicted output that is predicted by a model. And this is also supported by the quality metrics, as I told you while explaining the PPT, the PSNR, SSIM, RMSC, and the confidence. Now over here the confidence is 99.9%, which is not fake. I give you the assurance for that. This is because that currently the data we have used to train this model is only that which is given by the ISRO in the problem statement, as well as a little bit of our own data, and that's why the test data that we are testing and the trading data, they overlap quite a bit because we don't have a lot of data for the same, and that's why the confidence is so high. But we are planning on increasing the amount of data we are using in training so that we can even work with multiple test data. So also one more thing we want to add is different data types. Currently only TIF data type data is input, that is TIF based files can be input in the model, but we are planning on increasing the file types like PNG, JPG, because they are more common. And yes, this is our project right over here. The link for the same will be provided in the description. You can also come here and check in even without signing in. And if you want, the demo is already ready, and I will also provide the PPT link if you want with drive. And anything else, any doubt you have, you can always ask in the comments. Thank you for watching.